guys, welcome back to my system design series. If you are new to this channel and if you haven't watched the previous video, then kindly make sure you watch that so that you will understand today's concept in depth. In today's video, we are diving into the world of multi-leader replication. Now, that might sound super technical, but I promise you it is easier to understand than you think. Whether you are interested in tech or just curious about how modern databases keep your data safe and fast, stick around because we are breaking it down step by step. So let's get started. Have you ever wondered how your calendar applications keep your data in sync, whether you are using it in your phone, tablet or laptop, even when you are offline? Or how businesses with offices around the world keep their data in sync without waiting on a single central manager? Today, we are going to answer these questions and much more. But before that, make sure you have watched all previous 25 lectures so that you will understand what is replication in that. But here, let's do a quick replication. What is replication? In the world of databases, replication means simply copying data from one place to another. Think of it like having the multiple photocopies of your important document that you never want to lose it. Imagine you run a small bakery. You write down all the recipes in a notebook every day. To be extra safe, you keep the photocopies of your notebook and keep copies with your business partner. If something happens to the original, you still have the backups. That is replication. In databases, this idea led us to have multiple copies of this data in multiple regions. Traditionally, many systems use a single leader approach. Imagine there is only one single manager in your bakery who approves each and every update on the recipe. All the orders go through this manager. It means that if the manager is away or busy, no one can update the recipe. That is single leader model. But what if you have more than one manager? A system where every branch of your business can update their recipes. That is where multi-leader replications come into the picture. In this setup, each leader can act as both as a boss or team member to all the other leaders. Now let's compare both the approaches, single leader versus multi-leader, with a simple story. Imagine you have 3 bakery branches in Tokyo, New York and London. In traditional single leader system, all the changes from London and Tokyo must go through the New York. This can lead to delays and frustrations for customers waiting for their updated pastry recipes. Instead, in multi-leader approach, each branch updates its recipe locally. Your London team can quickly add a new idea without waiting on New York and then share the update with the other branches. It is like having local chefs with the freedom to innovate while staying synchronized. This approach drastically improves the performance because each branch can handle its own workload. But as we all see, it comes with its own challenges. When your system spans multiple data centers, like our bakery branches in the different cities, the multi-leader setup really shines. Let's break it down further. Let's talk about performance improvement. When you are in London, you want your order to be processed fast. In single leader system, your request must go to the New York first and then come back and then it will be processed, which will cause delay. But with multi-leader replication, the London branch handles it locally, making everything quicker and smoother. This means the customers can get the result faster, improving the user experience and keeping the business competitive. Okay, now imagine that the New York branch unexpectedly loses the power for a day. In a single leader model, it is a major headache. The entire operation will get stuck because it is waiting for the replacement leader. With multiple leaders, each branch can do its own thing and sync up later. This resilience is a huge plus. That was tolerance of data center changes. Now let's discuss the tolerance of network problems. Inter-data center traffic often travels through the internet, which can be unpredictable. In a single leader system, each network hiccup means delays for every single write. In contrast with the multi-leader system, a temporary network interruption in one branch doesn't stop the branch from processing its own local updates. So overall, multi-leader replication can give you the better performance and higher availability. But as said, every rose has its own thorns. Let's talk about one of the biggest challenges of this model. One of the trickiest part of the multi-leader replication is handling the write conflicts. Since each branch can update its data independently, What happens if the two branches update the same record at the same time? Let's say both the branches, London and Tokyo, tries to update the same recipe like adding the lemon in it. Which update should be accepted? This is the right conflict. Resolving this conflict might include merging some of the changes or deciding that one update has the priority over another update. Imagine you and your friend are updating the same recipe in the shared notebook. If you add extra lemon and your friend tries to add extra sugar at the same time, then you have to talk it out which updates goes first. This process of deciding which update to take, whether manually or automatically, is called conflict resolution. Some system uses the conflict resolution by using the timestamps, version numbers, or even the application specific logic. Advanced databases provides the built-in strategies, while other requires the extra tool, for example, Tungsten for MySQL, BDR for PostgreSQL, or GoldenGate for Oracle to manage it. Conflict resolution is very important when many more leaders are updating the same data concurrently. It ensures that even with the independent changes, everyone actually sees the consistent view of the data. Now let's talk about the offline operations. A situation where many of you can relate to. If you have ever used your phone in an area with a poor signal, so think about your calendar application. Even if you are not online, you can still add the meetings or see the schedule. How does this work? Your device is acting like its own mini leader. It accepts your updates locally and later syncs up with the server and with other devices when you are back online. This is simple example of multi-leader replication in action. Much like earlier our bakery example, each device handles its own operations. This ensures that the work continues smoothly even if you are in remote area. But remember, similar to our multi-data center scenario, there is still a need of conflict resolution if two devices update the same event. Now let's explore another scenario, that is a collaborative editing. How do platforms like Google Docs allow multiple people to work in the same document at the same time? When you type few words on the Google Doc, your changes appears instantly on the screen and shortly after on your friend's screen too. This is multi-leader replication at the work. Except in this case, each device is acting as its own leader. They update locally and then sync up with everyone else. To avoid conflicts, some collaborative tools lock the part of the document temporarily when someone is making the major edit. But if you see working it without delays or locks, that is the magic of very fine grained conflict resolution. Now to the level of individual keystrokes. Collaborative editing shows the power as well as the challenges of multi-leader replication when many individuals are working simultaneously. It is all about synchronizing and merging the changes effectively. Before we wrap up, let's talk about the challenges caused by multi-leader replication and what to watch out for. So these are some of the challenges. First is conflict resolution complexity. Second is potential data conflicts. Third is configuration issues. Fourth is increased system complexity. We are going to discuss all about this in the upcoming video, so let's move forward. While multi-leader replication has many advantages, it is not a silver bullet because updates can happen concurrently in each location. There is always a risk of conflicting changes. When conflict occurs, the system needs a robust way to resolve them, whether through automatic conflict resolution algorithms or manual intervention. In recent times, many modern databases and tools like CouchDB have built multi-leader replication into their design, making it easier for the developers to manage these challenges. Always be sure to understand the specific configuration and limitation of your database systems. Let's quickly discuss what we have learned today. First is replication basics. Copying data is like making photocopies of your important notebook. Second is single versus multi-leader replication. One boss versus several other managers handling updates. Third is multi-data center operations, enhancing performance and resilience by handling local writes. Fourth is offline operation. Your phone or device are acting as the leaders when they are disconnected from the internet. Next one is collaborative editing. Multiple users edit in real time with a smart conflict resolution. Next is challenges. Conflict resolution complexity. And system configuration issues. Multi-leader replication may seem like a complex topic at the first, but when you break it down with the everyday examples like bakeries or calendar, it starts making more sense. If you found this video helpful, then please make sure you like this video, subscribe to my channel because it will motivate me to make more videos. And if you have any doubts, you can comment down below. Thank you so much for watching.